Speaker's Corner aboard the Villa Vie Odyssey, hosted by Kit Cassingham.
Welcome to Speaker's Corner.
Hey!
Thanks for coming. You may recognize Carl from his visit in March earlier this year. Almost did last year, but still this year. Carl has a bachelor's from Stanford in electrical engineering. And he has a master's from the University of Colorado in atmospheric and oceanic, let me get this right, Carl, atmospheric and oceanic science.
We can't hear you very well, Ken.
Can you hear me now? Okay.
Yes.
Thank you. He has worked at NCAR, which is the National Center for Atmospheric Research, for 22 years. And for you movie buffs, NCAR was used in the movie Sleeper as part of that futuristic stuff that Woody Allen was spinning out. Carl is, in his own way, working with the future of science with forecasting models. His talk here, tonight he's going to take a sliver of his discussion for March, where he talked about the world's ocean currents. And we're going to compare that to the forest. And he's going to narrow this down to one of the leaves from that forest. Huh.
Yeah.
So welcome, Carl, in talking about crossing the Red Sea from a geoscience perspective. Thank you.
Thank you, Kit. I should preface by saying the geoscience perspective is tonight's topic. There is also the very obvious theological perspective talking about the parting of the Red Sea. And that theological perspective says God was in charge of all of this. God made all this happen. God is the primal cause of all the events related in the crossing of the Red Sea. And we praise God and are thankful that He delivered us from our enemies. So that's the Song of the Sea in Exodus 15. And we are going to focus on Exodus 14, which says exactly how this happened, where it happened, what things we noticed while this was happening. So Exodus 14, again, this is the narrative. And in the beginning of Exodus 14, it tells God tells Moses and the Israelites go to a very specific place. Go to Pi-Hahiroth, which is between Migdal and the sea, facing Baal-Zephon. So this is like real particular. Pi-Hahiroth is the mouth of the canal, which in the Egyptian Nile Delta, there's a lot of mouths of canals, so it doesn't narrow it down very much for us 3,000 years later. Migdal means tower. There's a lot of towers. Baal-Zephon means God of the North. So if anybody of you knows the latitude and longitude of these places, you should speak up, but they've been lost to history. So one of the goals of this conference that I talked at last June was to try to locate this place. And so some of this will be focused on where did this crossing happen. So those are three places, Baal-Zephon, between Migdal and the sea, and Pi-Hahiroth. So at that place in the night, Moses stretched out his hand over the sea. And the Lord drove back the sea by a strong east wind, and the waters were divided. And Moses went across. The waters were on their left hand and on their right hand. So that's the core of what we're going to talk about is this here, and there's lots of depictions of this happening. So that's the central part of this. Now, if we back up a little bit earlier in Exodus, we can see the 10 plagues, or the 10 signs and wonders. They're listed here, and these all have a natural component to them. So what we look at, we see the first one is the Nile River turns into blood. Okay, we've seen that with things going anoxic and a red tide. Then there's frogs involved and lice and boils and hail and locusts, darkness, death of the firstborn. All of these are natural components that are directed by God to do these plagues. So it should not come as no surprise then that the Red Sea, one of the biggest powers of ancient Egypt, it was also a natural component, namely wind and water. And if you want a short summary of what oceanography is, it's wind and water. Wind moving water. So this is definitely the province of oceanography. I'm not, by far not the first to analyze this narrative. This guy here, Major Bruce Tulloch, he was in the British Army, and shortly after the building and completion of the Suez Canal, he was out there surveying along the canal, and at night a big east wind came up, and he had to hunker down in his tent, and the next morning he found that Lake Manzala, this shallow body of water, was blown away. So like imagine you were at the Timea beach today and came in, there was a big strong wind, and next morning that lagoon there was empty out to the reef. You'd, wow, this is amazing, you'd say. And so he was amazed as well, but he also made this connection, wait a minute, this thing, I read this in the Bible somewhere. So he went back to his Bible and said, oh yeah, east wind dried out the sea, and he said, aha, this is, I observed another natural event of what happened here in a miraculous way to deliver Moses and the Israelites. So he published this in one of these very old journals and recorded some things like the depth of the water. So this is a long tradition of analyzing this event and some other events. I have a supercomputer and computer models that I can look at, so I can see things a lot more in detail than him. So this is kind of a little cartoon of Major Tulloch over there. The red is the lake, or Lake Manzala, about 2 meters deep, which is about 6'7", let's say. When a strong wind blows, I have drastically exaggerated the vertical scale here. That's kilometers and that's meters up there. All the wind sloshes to that end, to the downwind end of the lake. And the upwind end of the lake just empties out. It is dried, so dry ground. And there is storm surge over on this end of the lake here. So this is where people die in events like the Galveston hurricane and Hurricane Katrina. So this is very dangerous. This is less dangerous because it just dries out. But this is a well-studied phenomenon, and it's something that's very important to study to save people's lives. So this is what this looks like when the wind blows, and I've shown the circulation of the water here. It sets up a circular pattern here. So that's the force of the wind. In modern times, you can see this happening in a number of places. Lake Erie is one of the large Great Lakes, and it's also very shallow, and so it experiences storm surge and wind set down. When winds blow from the west, the area around Toledo is very shallow, and people have observed this. The lake is gone. It's gone over the horizon. There's fish there. So during windstorms, that happens. They also get strong storm surge on this end of the lake here at Buffalo. But more than one person, actually a little girl that I met named Ann Swain, she said, this is like Moses and the Red Sea. And so I think she carried that throughout her life until she saw me on TV talking about something. And so she gave me a call. So that was very sweet to hear from her. Here we have the northern reaches of the Red Sea. And one thing you notice with this is the models and the observations. Shallow water surges more. So things like the western coast, the Gulf Coast of Florida, has that shelf there that will surge a lot. So you get a lot of storm surge there when hurricanes go in a certain direction up the Florida handle, the peninsula there, and less when the ocean drops off real deeply. So what we have here on the northern part of the Red Sea proper is the Gulf of Aqaba here on this side, and the Gulf of Suez. The Gulf of Suez is very shallow. This is a bathymetry map. The Gulf of Aqaba is very deep. It's one of the faults. And when I did an experiment to blow wind from the southeast toward the northwest up the Gulf here, there was a lot more surge happening at the point here around Suez than there was anywhere along the Gulf of Aqaba. So this is about 1.6 meters, which is about so. And when Napoleon happened to be crossing the shallows up here, he was almost drowned. This is recorded in one of his journals from Egypt. So he's, maybe this taller so. Anyway, so this is dangerous here, and so we have a real experience from a very famous person that yes, this does happen. Another example. So let's look at the Exodus 14 text again. Stretched out his hand across the sea at night, and then all night long the wind blew. So we're going to extract some scientific details from this narrative, and I've kind of underlined them and picked them out. So the east wind blew all night long, so we don't know how strong it was, but it's perceived to be really windy. It's from the direction of the east, And all night long, we could just say this is 12 hours because this was at the spring equinox. So 12 hours worth of strong wind blowing from the east. So the computer modeler says, okay, I know how to set that up. It says the dry land, so it is going to completely remove the water. There'll be dry land there, maybe not dry to the touch, but you'll be able to walk out. There's no standing water, so that has to be part of the effect. And no escape. So the return wave is going to be pretty rapid. So if we're looking for something that matches the narrative, what we can pick out from the narrative, the return wave should really come back pretty quick. People have looked at this, and there's lots of proposals about where this happened. And everybody agrees that it happened somewhere on the margin of the Sinai Peninsula. That's this here. This is Egypt, and this is Canaan. I found nobody who claimed it happened at the Dead Sea. That's sort of the only other body of water nearby. So the good news is it's on this map. The bad news is just about every stretch of water here has been proposed by some person at some time as the crossing. So everybody's had their shot at places all around here. So that's way up. So, and then I entered the problem at this point going, boy, there's sure a lot of choices out there. What I noticed is I had already done some experiments. For significant wind set down to happen, you have to have a body of water oriented in the direction that the wind is blowing. So if you have an east wind, you want to have wind set down will happen sort of in east-west. But if you look at these bodies of water here, they're north-south. So these won't work very well just from a sort of back of the napkin point of view. This is the Red Sea proper here. The Red Sea, that's also the word is Yam Suf, which means sea of reeds. And so that's another clue here. If you're looking for something that's a sea of reeds, it's probably one of these lakes here because they have these papyrus reeds growing off onto the horizon. So just by name, not knowing anything else, that suggests something along here. Also, the fact that the east wind will act more on these coastal lagoons. So I looked at these closely, and there's Lake Manzala today and Lake Bardawil. Lake Bardawil is pretty natural the way it was before. Lake Manzala has been changed into a production for marine agriculture there. Also, big one, the Suez Canal was built right through the right third of it, so it's not the way it used to look back 3,000 years ago during the time of the Exodus. So I'm going to have to do some reconstruction here. I'm sorry. The lakes are the way they're still one here and one there, but with some obvious changes. So I'm going to take a look at these. They are oriented west-east, not north-south. So what does this look like in 1250 BC? That's my nominal date for the Exodus. There's a lot of controversy over that, the late date and early date, but for me it doesn't matter so much because I'm just looking at what the geology looked like at that time. The Suez Canal, I've already mentioned, the delta front has been prograding forward, so the delta is bigger. It's been pushing outward by loads of sediment, and so I want to pull it back 3,000 years. There were 7 branches of the Nile then, now there's only 2, and the Alexandrian branch and the Damietta branch, and there were lots of smaller canals through this. One of the big differences that happened when the Aswan High Dam was built is that basically became a sediment trap. And it used to be that the Nile would carry lots and lots of sediment out to the delta and deposit it there. Now the Nile River flows blue through Cairo, not brown like it should, but because the sediment is trapped up in Lake Nasser. So I'm going to take a look at some maps here. And this one I found is found in the library of the CU library, basement library. And this was made about 1800 using the writings of Herodotus, who was writing in 450 BC. So this is at least closer to the time of the Exodus than closer to us. He shows 2 large lagoons here. The one I'm interested in is the Lake of Tanis. And some other interest. So I said, at the eastern end of the delta, what's going to happen? Let's look at his map. Let's just see if he's correct. And here's the Pelusiac branch of the Nile, but I saw this place Magdalum there. And I wondered, that sounds like Migdal. And could it be the same place? Is this between Migdal and the sea somehow? What's the sea? Where's he going to be? So I contacted James Hoffmeyer, who's a respected Egyptologist and archaeologist, and I said, can that possibly be the Migdal of Exodus 14? He said, yes. Oh, this is pretty cool. Because what you have here is, I'm looking at this only from the view of an oceanographer. He's only looking at this problem from the view of an archaeologist. And he has come up with the same place. So two people working from different perspectives and different disciplines are literally within 10 kilometers of each other of where the crossing happened. So I'm all excited at this point, and that's a good thing. This conference that I gave this earlier version of this talk to was about transdisciplinary. So they are trying to bring together a bunch of disciplines together to focus on the problem. So they were happy to read that there is convergence that happens here. Now, parting the sea, how is that going to happen? So what's the hydraulic mechanism here? It's supposed to be water on left side and on the right side. And if, let's say, this was a shallow area of water here and the water receded, and I'm Moses and I'm running away across the dry stuff here, the Pharaoh's army could just run around, okay? So it works better for the story, and the story says that the sea's parted. So rather than just the chariots sneaking around, they have to follow me through the gap in the water. So here's my suggestion for how this happens. Is somewhere there was a bend in the body of water, and when the wind comes from this direction over by the bar and comes this way, all the water will slide toward me and it will split. Yes, is there a question?
No,
okay.
That's some sea.
Okay, so it's going to split this way, and if you're a bunch of people where Moses is, there's going to be water on your left and on the right. So that's the basics for how you're going to split water. So let's make this a lot more complicated. We're going to, instead of just having this idealized bend in the body of water, we have a coastal lagoon here. We have the Pelusiac branch of the Nile coming in here, and here's the bend. There's the crossing from the east wind, and here's the Mediterranean Sea. So the problem here is there is an input of water from the Pelusiac opening of the Nile, which could ruin everything. And this water coming in here could interfere with the dry crossing, and Moses wouldn't be able to get across, and my master's thesis would get denied, right? So that wasn't really what was going to happen, but that's what I kind of thought. This has to work, but then they assured me, no, this is for experimentation, and a negative result is just fine. So this is something I can't do on the back of an envelope. I have to look at this with an ocean model and run all the physics correctly to see if this is going to work. So doing so, I have to reconstruct all the geography there, not just sort of map it out. And in doing so, I used all these sources here. These are very much respected people who are looking at this problem and at Egypt during the New Kingdom period. About a third of them were at the conference, either in person or online. So I looked at these people, Manfred Vitek and Stephen Mosher, and like, well, these are the real sources here. I also was able to use some information that earlier investigators couldn't use or didn't have, which was this shuttle radar topography mission here, which gave me a real high-resolution terrain map of the Nile Delta. The Nile Delta is very flat, so you want a high-resolution model there. And so I was able to stitch this all together and use every square centimeter of their maps and map this all out with Google Earth. This is a picture of the Nile Delta from the shuttle radar topography mission. So I have increased the color scale here so you really look at all the details in the flatness of the Nile Delta. And if anybody has been there, it's just super flat. But there are these low ridges and low levees around the canals and around the watercourses here. There's some straight lines. You might be able to see one here and one here. That's places where the processors are stitching together the satellite passes, because the satellite goes over and repeatedly acquires the terrain. But this one here is a little bit curved, and that's a tectonic boundary. That's the boundary of the Sinai plate, which intersects there and moves against the African plate. So that is going to give some stability in the shifting sands of the Nile Delta. Other people have proposed there was an open sea there. So in other words, there was sort of this ragged coastline. I was always looking at a barrier island, and you are all, you've seen a lot of coastal oceanography so far, right? There's these barrier islands that form, and they are formed by the waves and the action of the sea coming down, and so you have this long strand of sand, a barrier there, and a sandbar that forms there, and that was that's present in the modern Nile Delta, but they are proposing that it's not there. So I said, no, you can't have that. The laws of the way the ocean works and the waves work and the sediment and the longshore drift, it's going to form these plumes of sediment along this area there, not just this ragged coastline. Just like you have a reef out at a certain distance, that's sort of a law of the South Pacific here. So I'm going to propose that, and I have some good reasons for explaining this to people, but that's my counter proposal here. So this is really the most controversial part scientifically of my hypothesis, and I called it the Tanis hypothesis for ease of reference. So I reconstructed it looking like this. Not so different from Reynolds' map, but we have a large coastal lagoon here, the opening to the Mediterranean, and then that tectonic line is along here. And this important place I called the Kedowa Gap. There was an archaeological site on the right part of that called Kedowa, Tel Kedowa, and that little gap is a lower gap where the Nile, the Pelusiac branch of the Nile debouched into the coast, into the Mediterranean Sea. Actually into the lake here and then into the Mediterranean Sea. So that's the spot. Here's again up here. Even while there is not much sediment flowing out the Damietta branch of the Nile, it still builds up these coastal sandbars here. So that's evidence for the fact that there is not going to be a ragged coastline. It's going to be a smooth coastal lagoon. We also have a map, and this is on one of the temples at Karnak, I believe. And this is Seti I returning home with captives. And he's very proud, and they're in chains and stuff, and he's like 3 times as big as they are because that's the way they exalted Seti I. But what we have here is a simplified map, and it shows a lot of stuff out here, a lot of people praising, a lot of activity, and a lot of habitations there that you wouldn't get if this were just open sea. Now this is a curious one. I came across this word, this hieroglyphic word. I pronounce it Tadenet. And this word is it's translated as the dividing waters because Alan Gardner, archaeologist in the 1930s, I think, said so called because they sundered Egypt from the desert. I said, okay, so it's a dividing line like the boundary waters between Canada and Minnesota. But I thought that there would be, what if these waters divide? What if this phenomenon was seen every now and then, every maybe 50 years or so, and the old people passed this down to their children saying, those waters divided once, I saw them split. And so I wondered if this term is reflective of what happens to those waters, not a statement of this is a boundary. So just these little hints that I started to notice. This is the delta across front section here. What it shows is this coastal lagoon and then very steeply dropping off there. That steep portion dropping off, sometimes there's slumps there and they will form a tsunami there. So that's another cause from tsunamis, is just an underwater landslide. So I modified the terrain using Google Earth. And I had a lot of Python scripts to write to do this. I ended up with something high resolution where you can draw polygons on Google Earth, and then and also stream or river courses here, and then it'll go and fill in that and say everything that's at this level here or inside the polygon put down to 2 meters below sea level. So I can reconstruct the topography pretty easily rather than going out and try to click every pixel down. So they were also interested in this because there's a lot of applications for this, not just in reconstructing ancient topography. So I give you the Nile Delta in 1250 BC. And what we have here is the Mediterranean Sea, just pushed back a bit, and a coastal lagoon here, the branch of the Nile, and then this configuration of coastal lagoons here that are sort of a little bit inland. And those are all shallow bodies of water. I put them at 2 meters deep. So I'm going to blow wind over this for 12 hours at a strong wind. And I went back and forth with my thesis committee. How strong is a strong wind? What's the strongest wind that you can walk into and still make forward progress? And they said, well, I've been up on Mount Washington. I've been in a hurricane. I used to walk around the parking lot at NCAR with the anemometer up there with my jacket above my head and just see how it felt. So we agreed on 62 miles an hour or 100 kilometers an hour. That's a medium strength storm on the Saffir-Simpson scale. So we said, that shall be the number. And you can make forward progress. Don't be throwing any frisbees, but you can go forward. So, okay, that's what we used. I had access to a supercomputer, which is nice. This one has since been replaced by a newer one, which is faster and bigger. But this is the one I used, the Blue Fire supercomputer, and the regional ocean modeling system for a lot of coastal oceanography. So there was a moment when I said, okay, this is all set up, and I'm going to start the run. It's like 5:30 in the evening, and I know it's going to take like 4 hours to run. And here goes. And I thought, oh, I'm kind of reaching out my hand and stretching it out and pressing the return key, and then I have to patiently wait overnight, kind of like Moses reaching out his hand and not so patiently waiting overnight. So I had this Moses moment there. And so in the morning, I plotted this and was thrilled to find out it works. So the brown area here is exposed mudflats. They may be dried up by the wind at some point, but that is the bottom of the sea that has been drained. And so there's this large area here of, let's just say, mudflats. There's an area to the north, and then the Pelusiac branch that I was so worried about, it comes in here, but the wind is just going to stream it across downwind. It doesn't get in the way of the crossing. And a curious thing I noticed here is the crossing here is 5 kilometers wide, about there to there, 3 kilometers long, and remains open for 4 hours. So in every description, every artistic depiction you've ever seen of the crossing of the Red Sea, it's pretty narrow. And there's sort of like, there's walls there, and there's a wall there. It's a real narrow thing. The Bible never says that. There's nothing that says it was a narrow opening. They just went across, and to the group of people, there's water over there, and there's water over there. So if nothing else, we can at least up the game on the biblical interpretation and say it doesn't say that. There's no indication that it's a really narrow opening. So I was very thrilled with this, and 4 hours seems, you got to get a bunch of people across, but width is not a problem. There might be some other problems, like it's going to be dark, and they're going to be walking into a 60-mile-an-hour wind, but this alone, that's what you have to work with, Joshua and Moses. So this is, and X marks the spot. There's the Ketowah Gap there, and so Moses is here stuck at B. Now, according to the story, the chariot army is approaching him from the rear, but they can't really get to him very well because there's water on both sides. So the water is protecting them. And I've asked the guy who was in the Marines, I said, you don't really want to get stuck like this, but it's not hopeless, is it? And he said, yeah, you're protected on 3 sides, and you got to watch out for people coming this way. You don't want to get packed in. But he said it's not a disaster. You have to evacuate eventually, but it's not so bad. Now, the walls of water puzzled me for quite a while. I looked up the word Chalma, and it's usually the walls of Lachish, the walls of Jerusalem, the walls of Hazor, and somebody's always breaking down somebody else's walls in the Bronze Age. But in a few cases, it's protection. If you remember the story of David and Abigail, Abigail says, David's men were like a wall to me and protected me all night long. Okay. There's also Nahum 3:8, which says that the Nile River is the wall of Thebes, which was on an island in the middle of the Nile River. So it's a protective feature there, not a vertical wall of water. So I'm going to address that not through hydraulics, but through biblical interpretation. And this kind of makes sense because, when we think of walls here, They're for keeping out the cold. They're for running plumbing and Cat 5 wiring and all this good stuff. Walls in the Bronze Age, they kept you safe. There's all sorts of things out there, people that you don't want to come in, and the walls, you hide behind them to keep safe. The return surge. So I have this great ocean model here, and I can tell what's going to happen when suddenly the wind stops. The water comes back at a standing wave at about 15 miles an hour, which is pretty fast. People can run that fast for a sprint, but when there's confusion and chariots and horses tumbling, it's going to be really hard to get away. So this return wave comes in at the depth of 2 meters at 15 miles an hour, and the surge comes through from the south here first, and sort of pops out into the open. Then this big wall of water comes here and smashes through in that direction. So if anybody's looking for debris, chariot parts, they should be found along this coastline here, mostly on the north side. So I'm trying to tell the archaeologists where to dig, or more likely where to run their ground penetrating radar, whatever they use these days. Another thing it came about with this, you'll notice these arrows here that plots the current, so there's very strong currents in here, and there is some reference to this kind of same place as the place of the whirlpool. So if this thing is a natural event most of the time, it will happen and there will be strong currents right there. So the conference was interested in the route of the crossing, and so with this in mind, I can put together the entire crossing here. And what they are going to do is they're going to cross the Pelusiac branch of the Nile at Daphne here, which is Taphanes in some of the other ancient sources, cross there using whatever methods they had to cross these branches of the Nile River during the Bronze Age of Egypt, boats, maybe some kind of bridges, and then get stuck out here. This is the between Migdol and the sea. Migdol is here, so the sea is there, sort of between Migdol and the sea. But there's some seas here anyway. So they are in some sense between Migdol and the sea. They're at the mouth of the canal, and I guess I just put Bel Zephon over here at the place later called Pelusium, because it's just out there, it means God of the North. So they are going to do the famous turn back. So they get to Etham, and here get to Etham, all ready to go. No canal at that point, but God says turn back and go north, and so there's no further information given, but they turn back and go to the north here, get stuck, and then after the crossing they go south. So this was especially interesting to the conference because this is a plausible route. And then the overall route looks like this. Even though there is this hook to the north, the other text says we took the southern route here because we did not want to go through the coastal road because there's lots of armies going back and forth and we wanted to avoid them. So they took the southern route. So this fits with another remark that's given, that this is to the south. And then I put Mount Sinai, so there was a lot of discussion about where is Mount Sinai. Most of the people wanted to be in the southern Sinai Peninsula here, so I just said that's not my issue, but I'll just put it there at the traditional spot, and if you want to move it around, we can see if this can work. So that's generally how we approach this. So here's the spot, Tel Ketewa. So you can go in and Google Earth and just zoom in on this thing, and there's this little triangle there, a little square, and I thought, what's that? It's probably some ruin. It's not from the New Kingdom period. It might be like Persian or something like that. So there's a lot of ruins all over Egypt, and they're all called Tel for something. So this is Tel Ketewa here. So that's the spot where they, and I've given you real accurate latitude and longitude here. So that's where they stumbled out of the gap and, wet, maybe muddy, exhausted after being up all night. And they were alive. They thought they were going to die the night before, and they were alive there. So that's where Miriam and Moses sang and played the tambourine, and that's where they celebrated. That's the spot there. Probably a bunch of them just collapsed. That's the ending point of the crossing. And from there, they gathered themselves together and said, we're safe, our enemies are gone, we're going south. And I was not able, I visited this place when I was filming a documentary but we were not able to go across the Suez Canal. So I would love to be at this place, but I haven't set foot there. And I was just hoping to see some lines of sight that I can't really get with Google Earth. But yes, you can zoom in on these places and look at it. Interestingly enough, the area around here is really agriculture. So if you want to go looking, you don't have to move big buildings. You can go ask permission to dig in somebody's field, and hopefully they'll give it to you. So for the conference, I asked, okay, we need to resolve whether there really was the coastal lagoon that I suggest or not. And so I proposed that a transect of sediment cores be run north through this spot. And I don't know, so people do that, and they do it for reasons that don't have anything to do with biblical archaeology, just to see what the Nile Delta is doing in Egypt. But I also said, okay, this is the logical next step in the hypothesis. And I said, like Elrond here, one of you must do this. And so they sort of, okay, we'd like to, but there's funding, permission, all sorts of stuff like that. So, so this is a picture of what I was proposing here. If we really wanted to do this, all hands on deck, we would run some sediment cores north. But Stephen Mosher stood up and said, is there any list of lakes in that time of Egypt that we can work with? And so he asked this question. In other words, so for example, they're probably going to be listed in some sort of sensible order. Now, if you don't know where Raiatea is, but you know where Bora Bora and Morea are, and you saw this on the ship's itinerary, you'd probably say, well, Raiatea is kind of between Bora Bora and Morea, because people sensibly list things in that order. So we're looking for something like this. And Manfred Vitak said, yes, and look up the full text of the Onomasticon of Amenhotep. It's like, that sounds really Egyptian. And so I haven't found a good English translation of that, because I'm trying to match names and figure out what the other one is. So I still have to do this, and there's a paper that's in draft, it's in manuscript, and I want to finish that portion for this. So I have to look up this and and see if his suggestion will avoid taking a lot of sediment cores. So a few more concluding thoughts on the Exodus. There's a lot of questions about it. Did it happen? Obviously, but I think I have suggested a plausible scenario here, which attributes God as the ultimate cause, but the things recorded in the narrative do make sense. I pick a late date. This is not so important to me, but the 800 years listed in, the 800 years listed here are actually generations. So it's not exactly 40 years each one. So that accepts a late date here. Exodus, so there's a lot of talk about Exodus 14 and 15, which one's older, what's happening there. And I asserted that they're both near eyewitness accounts. So these happen, they started to write things down. Somebody sang a song, and somebody recorded it in some sort of fixed form, and that is near the archaic vocabulary and style that we see today in that original, what we have as the text for that. So I'm saying that these are near eyewitness accounts, and things like the wind direction don't show up in any other account, but there it is in Exodus 14. So they reported the wind direction because they were there, but somebody else doesn't think that's important, and so when they repeat it, they have other things to talk about. So stuff like that. Then there's this problem. The Bible states, or your King James Bible says, that 600,000 fighting men were present there. So that's an enormous army, even in modern times. And just getting them all to face the same direction is a big project. So this is unrealistic for the late Bronze Age. And people have pointed that out for quite a while. There's some other things that are noted in the text. They're afraid of 600 chariots. So if you have 600,000 guys and 600 chariots approach, you shouldn't be afraid of them. You outnumber them 100 to 1. No, 1,000 to 1. And even if they carried 100 arrows each, a sheaf of arrows, and they couldn't even hit you all. So it's really nothing to be afraid of. So something's going on wrong there. we are reported that there's 2 midwives, and if there's 600,000 men of fighting age, that means there's 600,000 women of childbearing age. Are they going to be served by 2 midwives? No way. And I thought, okay, maybe they're just co-chairs of the midwives co-op, but it doesn't say anything like that, and you have all these other things in there as well that are sort of suspicious. For those of you in management or wondering about like the proper way to manage things and levels of management, stuff like this, Moses ends up with 700 direct reports here, which is a lot to manage. And so that's another idea that something's wrong with that number. So that's my suggestion, is to go to, actually it's not my suggestion, Kenneth Kitchen said the word LF means 1,000 in some contexts. It also means 1 squad of soldiers. So when you read things like Reuben was 46,500, it should be understood as 46 squads numbering 500 individual soldiers for about 10 per squad. So that makes the numbers a lot more sensible here. Let's see, so my job now, I've done all the ocean modeling I could, I've done all these other things and help people out, and people are citing my paper. So my job now is to publicize and explain the hypothesis in front of the research community, and what better way to publicize it than to get myself a pair of custom license plates that say Migdal on this, because I just got a new car and I had to get this, and so that's my license plate in Colorado. So I can't wait to get home and put them on my car. So that's what I've got, and there's a lot of other things I do, and so I'll be happy to take any questions.
So knowing how the lay press works, did you ever have anybody say, publish an article that said, government scientist proves that the Red Sea crossing was real?
So the idea, so the prove is the idea, and there also the government is at issue here as well.
I know.
So proof is for mathematics. When you look at history, you have to look at, this is the evidence, the preponderance of evidence. So I stay away from the word prove as much as possible. Research was done at the University of Colorado at Boulder, and they take a very open approach, saying if you get 4 thesis people to approve it, and you want to work on it, then you should do it. And so the fact that this is an ancient story that has a religious, obviously, it's a religious text, it's a historical text, it's all sorts of things. It uses an awful lot of oceanography, and it uses geology and reproduction of terrain modeling and satellite data. It is perfect for a master's thesis, frankly. And so they said, go ahead, yeah. So, and as far as the government funding, NCAR gives me, they pay for everybody to get a master's degree. So as part of this. So they can't really say, they really don't want to say you can do this and you can't do that. It's, if the CU approves it, they go ahead. And they give you the fair accounting. Everybody gets an allocation on the supercomputer. So it was all good to go. They actually were interested because it showed the value that ocean modeling can do and that NCAR can do for other disciplines. Like we are sort of working with the University of San Diego on their cyber archaeology here, because that's the guy who invited me to the conference. So the transdisciplinary thing works out very well. So that's the long answer to a simple question with the 2 issues of the funding and the proof. Yes?
If I understood you correctly, the waters were parted for 4 hours.
Right.
It seems like a very short time for the seabed to be dry enough to walk across.
So the question about the dryness of the seabed, I didn't pay much attention to that when I was running the model, because it's either it's the depth of water and then it goes down to 1 centimeter and it goes to 0 and it's dry for me and I'm happy. So, but people kept asking me this question about is it dry to the touch or are they going through mud? There are cases that somebody is like the crowdsource everything. Somebody named Pamela Zohar showed up on one of the chat lines and said, wait a minute, in Utah, lakes blow dry overnight. These lakes out of the salt flats, they blow dry overnight, and then they form this thick crust in a very short time. And you can walk out there, but every now and then somebody tries to drive a car out there and they get stuck. So the surface can dry out very quickly with a strong wind blowing, especially a dry east wind. And so that was, I just said, there, thank you, Pamela. That's what we have here. Yeah.
You commented very quickly that Napoleon had attempted to cross, or that's the story associated with it. Where was that? And is there historical facts on that?
Yes, the Napoleon account is from his travels in Egypt, the official account of his expedition there, along with these incredible diagrams of all the fish and statues and stuff that he saw. So he headed out, and then he headed back, and in one of them it was the combination of the tide and the wind, and he was going through the shallows there where the Suez Canal is now, and at the very northern tip, right at Suez, and that's where he got into trouble.
Well, are you or other people at that conference actively planning to do a project to sink cores into the area, or is that just a pipe dream?
That's the ask, and I understood that it was a strong ask to say, okay, one of you must do this, to go out and every so and so on dig cores. So every now and then, though, you come up against somebody who says, oh, that's what I do. And that's what I have paid to do, and I'll do it conveniently in your transect if there's a good reason to. So it's the kind of thing you want to throw out and maybe somebody will pick it up. But in this case, I didn't see any takers, but I did see somebody who said I should look at the Astromicron aminoPP. So that thing. And there's a Wikipedia article, as you can see, so I'm going to take a look at that. Yeah, Lisa?
Okay, not to get too political, but from Boulder, our Colorado governor didn't release Trump, somebody, but they threatened to shut down NCAR. NSF, NCAR? What's the status of that?
The status is, so this happened like a week ago. So the Russell Vogt, the OMB director, said they would announce they're going to dismantle NCAR. And so what has happened is the Colorado representatives and senators have said no, and they're using what they can to influence the decisions that are being made. So yes, my job is at risk here, and so I am concerned about that.
You could stay on board with me, but no.
It's very tempting, yes, absolutely. So that is going on. In the meantime, I'm really supposed to just keep doing what we're doing, so here I am giving the talk. Yes?
Okay, if you could bore like you would like to, or somebody would like to, what would you hope to find there that would give you some kind of acknowledgement that it happened? What would you need to see?
So I've seen the diagrams of the cores, and I'm just puzzled as to how they do this, but other people say this means that this was a shallow, a deep water environment of the sea, and then the shallow water environment, and then this is coastal, and then this one here, because these little papyrus reads, that means it was now lagoon, and then here's dry stuff. So they can read this, and they can get a date on all these, so they can sort of find the 1250 BC layer and just mark it out. So it's amazing. But yes, people can read sediment cores, and somehow they pull up the cores without without turning them into just sand. So
you're not looking for tire marks?
No, not tire marks. Footprints or something, yeah.
Chariot marks.
Yes, Kit?
I want to go back to NCAR's challenge. About 100 years ago, Colorado's government was run by the KKK. And they said to the University of Colorado, thou shalt not hire people of color, Jews, people we don't like, etc. And if you do hire those people, we are going to cut your funding. All the staff, professors, everybody got together and said, what do you want to do, gang? Should we let them have their way, or should we find a solution? So they all agreed to reduce their salaries enough that everybody could get a little bit. And so they survived the state defunding them. I'll hope that NCAR can do something similar with the state's help.
Yeah, we have, I've heard announcements, and this is public as well in the Daily Camera, they cut some of our benefits and a few things like that, and they sort of could absorb a cut to in the 5% to 10% range, and things would be cut. But this seemed to be a much bigger threat than a 10% cut. Okay. Go.
And I've got the microphone
Yeah,
now.
go ahead.
Hi. And forgive me, I was 15
Lori.
minutes late. So,
To your mouth.
I was 15 minutes late, so I may have missed some of what you've already addressed. My daughter's also a geoscientist and is also facing tremendous cuts at her university in Pennsylvania. But I guess what I'm wondering is, you were linking history, and of course you've only got to work with what you've got to work with, so you were quoting Bible scriptures in terms of history, then in terms of what these people were dealing with scientifically on the ground as interpreted by you as a geophysicist. And you may have already addressed this. I'm wondering what your personal perspective is. If you mentioned that earlier, as a scientist, are you also a religious person?
Yes, I am, and that was actually before the first slide. So this was a geoscientific view. The theological view is that God is the prime mover of all these events described in this Exodus narrative. And God sent the wind, directed Moses to the right place, blocked Pharaoh. So God is the director of everything that happened here. And that is the theological view that is expressed repeatedly in the Song of the Sea, which is Exodus 15, which doesn't have so much scientific stuff, but it is all about praising God for delivering his people.
And then following up on that, I'm just curious then, as we visit, and as you and Lisa get to visit all these magnificent places on our planet, where, like the other day, I visited a place where they had performed, I guess, eons and eons ago. I don't know if there was any written text like the Bible, but certainly handed down by word text about great octopuses doing things. They had made human sacrifices. They definitely had deities
Right.
throughout the millennia and then throughout the world. And maybe this is much bigger than you want, but I'm curious about you as a scientist, as a human being, about as we go around and encounter all these other traditions of God active in the world. As a scientist then, how do you accommodate all these other beliefs that are either not true or I'm just curious.
Well, the one that comes to mind is Crater Lake in Oregon, Mount Mazama, and so the scientists have dated this to a certain time, let's say 7,000 years ago or so. But among the Klamath Indians of that era, there's stories that, like, this god got really mad, and so it is very strongly attested that they witnessed this eruption. So they attributed the action to their gods that they believed in, but in terms of a narrative, their narrative makes sense as well, that this was a volcanic eruption. And so I think their story is plausible, that they really easy to connect. So that's the one that comes to mind. Anything else? Well, thank you all for coming.
Thank you.
And I'm available for private questions until midday of January 1st.
Well, we want you to come back No offense, but not real quick. Keep that job going, okay?
Okay.
And bring us more stories next time you come. That's good. So, fascinating blend of religious text and science.